Hello, in this video let us see about rotary actuators and process control valves. All the explanations and descriptions are based on the reference book Mechatronics by W. Bolton. Let us see rotary actuators. We are familiar with linear actuators where there is linear motion that we get based on the control signal. Typical piston cylinder arrangement is an example. We have seen single acting, double acting cylinders and all. These were examples for linear actuators. Now let us see rotary actuators. Rotary actuators are meant for getting angular or rotation motion based on the control signal that is received by the actuator. In this diagram, we see two categories of actuators, rotary actuators. One is semi-rotary kind of actuator, another one is a rotary kind of actuators. Semi-rotary means it will not provide complete rotation, whereas rotary actuator that will give complete rotation. When we get complete rotation, we call it as motor. Now, let us see other examples for semi-rotary actuators. One is a case where linear cylinder is used to produce angular motion. Here there is a linear cylinder. When the signal gets in the cylinder, the piston will move. This movement is reflected as angular motion of this stem. So here the linear motion is converted to angular motion. This is an example for rotary actuation, semi-rotary actuation. Here there is another example. It is called as a vane type semi-rotary actuator. We are familiar with vane pump. Similar kind of arrangement is seen here. There is a casing. Inside that there is a rotation element. A rotary element is attached with a vane. Okay. There is a sealing between the vane and inner surface of the casing. That means we get two airtight chambers, one here and another here. So for this arrangement, there is pressure supply possible through this port as well as for this port. Based on the pressure difference between the fluid supply pressure available here in this port and this port, the vane will move this way or this way. So depending on the pressure difference that is supplied on either side of the vane will move. So that movement can be used for actuating something. So this is an example for semi-rotary actuation. In this case, we see a vane motor where there is a rotor at the center. It is an eccentrically placed rotor. There are many slots inside the rotor in which vanes are attached. These vanes are typically spring loaded so that always the vanes are in contact with inner surface of the container. Now, when there is movement happening for the rotor, then this will the vane will also move, and the vane will always make contact with this because of the spring load. So the result is that because of the vane and the positions, there will be many chambers, independent chambers are generated inside this. Now for the functioning, when there is power supply through this, pressure supply through this, then it will have a tendency, the rotor will have a tendency to move in this direction depending on the pressure difference between this port and this port. So if there is higher pressure on this side, it will move in the clockwise direction. If there is higher pressure from this side, it will move in the anti-clockwise direction. So depending on the pressure difference, it will move clockwise or anti-clockwise. In whatever be the case, complete rotation is possible depending on the pressure, the duration of power given through fluid, hydraulic or pneumatic power given to this vane. Since it is giving complete rotation, we call it as a vane motor. Now let us see about process control valves. Process control valves are used to control the rate of fluid flow when a flow to a tank or a duct is to be controlled. And it is an actuator that moves a plug into a flow path, thereby altering the cross section of a flow. Pneumatically actuated stems are controlled by differential pressure on a diaphragm is used to move a plug into a flow path. The plug movement controls the flow rate. I will explain the concept based on the diagram. So this is a control side of a flow control valve where there is a diaphragm here. You see a diaphragm here. Diaphragm is typically a rubber which is sandwiched between steel rings. That means it becomes rigid, but there is flexibility at the center. So there is control pressure applied from one side here, and on the other side of the diaphragm there is atmospheric pressure. So the diaphragm is connected to a stem, and that is spring loaded also. So because of the spring load, always the diaphragm will have a tendency to go upward direction. So that will be the normal condition of the diaphragm. It will be in the upward direction. Now when there is pressure applied through this port, pressure can be through hydraulic pressure or pneumatic pressure. Typically this kind of valves are controlled by pneumatic compressed air. So when compressed air is given to this, based on the pressure given by the compressed air, this diaphragm will push downwards. So what happens is the stem will go downwards. So when there is when the pressure is removed, the diaphragm will go back to the original situation also. Now let us see what happens when the stem goes downwards against the spring load here. Now you see here in this diagram, this stem, spring loaded stem, is connected with a plug here. So the plug is placed in the fluid flow path. This is the fluid flow path. Okay, this is the fluid flow path. So this is the plug, and these are the openings. So normally it is in the upward position. This diaphragm is. So naturally, if there is flow, the fluid will go like this and will go through this. When there is pressure applied in this, what happens is the plug will be moved into the flow path so that the flow will be restricted. So that is the reason why this is controlling the flow rate of whatever fluid that goes to this duct. This is the fundamental principle of a process control valve. Here you have to remember that normally this spring will make the diaphragm in the upward direction. So it will always be open if this is arrangement. So we can call this condition as a normally open kind of arrangement. Let us see the types of valve body and the plugs. There are two kinds of valve bodies, valve plugs are seen generally in process control valves. One is single seated, another one is double seated. Single seated means the flow will be permitted through only one opening, that is single seated. If it is double seated, the flow from one direction will be permitted through openings, one here and one here, through two openings. The single seated valves are generally more tightly closed in most of the cases, but it will require more force for controlling, whereas double seated will require less force to control the flow, and it is less tightly placed on seats. Now we have to be familiarized with two words, that is normally open valve and normally closed condition. I have told you that this stem is connected with the diaphragm. Diaphragm will have a general tendency to keep upward position because of the spring that is connected with this stem. So when there is control pressure happening from the top side, what happens is this plug will go downwards and it will come in contact with the seat so that the flow will be arrested. That means the flow will be arrested or the control is happening only when there is pressure from the top side. Otherwise, there is, in the normal condition, there is flow. So such an arrangement, we call it as a normally open kind of plug arrangement, valve arrangement. This is a diagram showing single seated normally open arrangement. Now let us see this diagram where it is single seated again, but when there is pressure, no pressure, it is in the upward direction, and this will have a tendency, that is this plug will always be in seated with this because it will move in the upward direction in the normal condition. So in the normal condition it is in the closed stage. If you want to open it, what we have to do is we have to apply the control pressure on the top of the diaphragm so that this stem will move downwards. Once it is moved downwards, there is flow permitted in this direction. Since it is normally in the closed condition, we call it as a normally closed single seated valve. Similar is the case here also, normally open condition, that is since normally it is in the upward direction, so it is in the normal open condition, and when there is control pressure from the top side and thereby moving the stem downwards, then these two seats here and here, it will be closed so that the flow will be arrested. So this is double seated normally open situation. Here similarly there is a double seated normally closed condition. That means it will be, since the pressure is always against spring load, it will be in the upward direction, the passage will be blocked in the normal condition, so we call it as a normally closed. If you want to open it, you have to apply pressure in the diaphragm through control by control means, so that the stem will be going downwards, then the opening will be generated. So normally it is in the closed condition. If you want to open it, you have to apply pressure from the top side. Now let us see some kind of shapes for the plug in order to control the flow rate. The shape of the plug will determine the relation between the step movement and the effect of flow rate. Generally, three types of plugs are used, and that is shown here. What we have to understand from this diagram is that if this is a kind of plug, we know that when there is movement for the stem, this plug will be introduced in the flow path. Depending on the cross section that is available on the flow direction on the plug, the flow rate will also be controlled. So here we are seeing three types of cross sections, kinds of plugs. Here in this case, it is called as a linear contoured plug, because the name indicates that when there is a particular movement for the stem, corresponding variation in flow rate is happening. That is, the relationship between the linear movement of the stem and the change happening for the flow rate is in the linear relationship. That is shown in this diagram. This is a linear kind of contour output. This kind of plug, if it is used, what happens is it is equal percentage. That is, if there is a particular percentage change in movement for the stem, that many percentage change in volume rate will happen. So this is the equal percentage contour. Now there is another stem that is having this cross section where it is called as a quick opening kind of plug. Here the feature is that initially there won't be even if there is movement, then for the stem there is no appreciable opening happening. At a particular limit, a quick opening happens, appreciable change in flow rate happens. So it is called as quick opening kind of plugs. So in this session we have seen rotary actuators, control valves, and certain terms like normally open, normally closed kind of things. Just verify, can you answer these questions? If cannot, please go back and see the video. I strongly advise you to go to the reference book of Mechatronics by Bolton to get more information about this content. For the sake of concluding of hydraulic and pneumatic circuit, I would like to give you an exercise. You might have seen this kind of car park barriers, and imagine that if the barrier is operated by means of a pneumatic circuit. So the question is, a car park barrier system lifts a horizontally positioned barrier when money is deposited in a coin switch box. This is a common situation that we see in our parking areas and the malls and all. So the barrier goes up to a vertical position to allow the vehicle to pass. Then it comes back to original horizontal position. Develop a suitable physical arrangement for the system by using pneumatic elements or hydraulic element. Okay, arrangement you have to make. Develop a pneumatic circuit for this system. This is a work that is given as an exercise. You try, if you can do it. So with that, we are coming to the end of this pneumatic and hydraulic actuation systems. Thank you.